Okay, so we're going to try exercise 2a, question 1. Okay, so we've been told the set S is equal to x plus y root 3, where x and y belong to the integers. Okay, so we have x and y both belonging to a set of integers. Okay, and we need to determine whether each of the following is a binary operation on S. Okay, so the first one, part A, asks us to have a look at subtraction. Okay, so let's consider set S under subtraction. Okay, so let's take two elements, okay, S1 and S2, and let's subtract them, and let's see if the following element, the subtracted element, is still in S. Okay, let's see if it obeys closure. Okay, so we'll take S1 to be A plus B root 3, and we'll take S2 to be D plus C root 3 as well. Okay, so let's combine these two elements using the group operation. So we'll say S1 minus S2, and that is equal to A plus B root 3 minus D minus C root 3. Okay, so we can just collect like terms now. We can say this is equal to A minus D plus root 3 lots of B minus C. Okay, so well, we of course have to define here as well that A, B, C and D also belong to the integers as well. That's just a small little statement that we should have defined at the start as well. So if A belongs to the integers and D belongs to the integers, we know that the integers are closed under subtraction. So we know that A minus D belongs to integers, and the same can be said for B minus C as well, actually. So B minus C also belongs to the integers. Hence, we can say that this group, this set, sorry, is closed under subtraction. Okay, essentially that this set forms a group with respect to the binary operation subtraction. Okay, so we can now have a look at the part B, which asks us to do the same thing for multiplication. Okay, so again we're just going to define two elements, S1 to be A plus B root 3 and S2 to be C plus D root 3. I have to do the ABCs in my head where A, B, C and D all belong to the integers. Okay, so now we're going to consider S1 multiplied by S2. Okay, so that's going to be given by A plus B root 3 multiplied by C plus D root 3. Okay, and we can just expand that out, and we see that we will get AC plus AD root 3 plus BC root 3 plus 3BD. Okay, of course you don't need to worry about the order in which you write the letters, because we know that multiplication is a commutative process, so it doesn't matter. So again, just a bit of simplification here. We say that this is AC plus 3BD plus AD plus BC, obviously just factorizing out the root 3. And perfect. So we know that the integers are closed under multiplication and addition. So we can say that AC plus 3BD belongs to the integers if A, B and C, D all belong to the integers, and that AD plus BC root 3 also belongs to the integers as well. Okay, so again, the gist of these questions is that you consider two different elements, and we define those elements to be in the set S, multiply them out, or perform whatever binary operation we've been asked to, get it into the original form so it looks like, so the original form was x plus y root 3. Okay, that was the original form, x plus y root 3. Everything in the set looks like that, essentially. Get it into that form and show that each of those things, so this is kind of like something plus something root 3, and we have a something here and a something root 3 here, so we kind of match it up. Okay, so let's have a look now at just the last part now. part C, which is just division. Okay, so again, we're going to define two elements, S1 and S2. So S1 is going to be A plus B root 3, and S2 is going to be C plus D root 3. And again, we're going to say that A, B, C, D all belong to the integers. And then we're just going to divide those two elements. So we're going to have S1 divided by S2 is equal to A plus B root 3 over C plus D root 3. And then, of course, at this point, we can rationalize the denominator. Okay, so we're going to multiply top and the bottom by C minus D root 3. C minus D root 3. Okay, so the reason we're rationalizing this denominator is because we don't like having irrational things in the denominator. That's just kind of a general rule. But as well, we want to get it again into that form x plus y root 3, so we can evaluate the x and the y essentially, and show that both those things belong or don't belong to the integers. Okay, so when you expand this out, you're going to get, so expanding out the top, you're going to get AD, and I've already collected the like terms as well, minus 3BC plus BD minus AC lots of root 3 all over. So in one step I've expanded it out and I've collected all the terms that contain a root 3, and I've just factorized that bit out. And then on the bottom we're going to have C squared minus CD root 3 plus CD root 3 cancels out, minus 3D squared. Okay, minus 3D squared. Yeah. So at this point, what we can do now is just, so I'll change to red here, is we can take this part of the fraction and this part of the fraction, and then both express both of those terms over the denominator, okay, because they both share the same denominator. So we can say this is equal to AD minus 3BC over C squared minus 3D squared plus BD minus AC all times by root 3 over C squared minus 3D squared. Okay, so here we have a bit of a problem, because if we take an integer and we divide it by another integer, we may not get another integer out of it. Okay, so for example, let's say we take A to be 1, and so we'll say A is 1, B is 1, C is 5, and D is 5. So this term here will turn out to be AD, which is 5, minus 3 lots of BC, which is 5 minus 15, I believe, yep. And that's going to be divided by C squared, 25, minus 3 lots of D squared, minus 3 times by 25. Okay, so what we can do now is we can just compute that on our calculator. So I'm just going to plug that into my calculator. So I get 5 minus 15 over 25, take away 3 lots of 25. Okay, and that gives me 1/5. Okay, and 1/5 does not belong to the integers. Okay, so in this case, S1 divided by S2 will not belong to the integers. Hence, this group is not closed under the binary operation of division. Okay, so we just write a little statement saying the reason why. Okay, because we essentially, so we've generated two different elements, S1, S2. We divided them, we put them into the form x plus y root 3. So this is our x essentially, and this is our y, and we've shown that when A, B, C, and D have certain values, these things do not belong to the integers. Hence, we can say this set does not form a group under the binary operation of division. Okay, so I hope that helped, and thank you very much for watching.